All right, so I want to make sure that you're not making really bad math mistakes. This is not equal to this. Really, really wrong, right? I just showed you need to do a u substitution. So the only time you get ln, if it's exactly 1 over u du, then it's ln of u, right? This is really wrong. So you can't, when it's squared or when it's cubed in the denominator, it doesn't turn out to be ln. You have to do a u substitution. And I just showed you on this one, like if I let u equal x minus 1, du is dx. So go super slow, 1 over u squared du. Take the time to rewrite it. Add 1, remember antiderivative increase. Add 1 to the exponent. And then I'm always going to suggest you rewrite it and then put the negative exponents in the denominator, then put the x's back in, right? Same thing with this one. So let's just go through it just so you really, really see it. I'd let u equal x minus 1, du is dx. So I get 1 over u cubed. So that's the same thing as saying u to the negative 3. So taking the antiderivative, I'd get u to the negative 2 over negative 2. So negative 1/2, 1 over u squared, and then put the x's back in, plus a c. Okay, and I just want to remind you, because this is going to be coming up, remember the arctangent, if it's got the a, this one has the a, 1 over a on the outside. All right. So let's dig into this case 3. All right, so here, always factor the denominator first. So I left it unfactored to kind of make sure I point that out. You have to factor the denominator first. The degree of the numerator is smaller than the degree of the denominator. Good news, no long division necessary. So this x is a linear factor, so x to the 1 power just has an a over it. X squared plus 4 is irreducible, not factorable, quadratic, so it's bx plus c. So you know this can be factored, right? Oops. This difference of squares can be factored, but addition of squares cannot be factored, right? So that's an irreducible, not factored anymore, quadratic. All right. So then what do? Is I multiply both sides by the denominator, x times x squared plus 4. So these cancel, so I'm left with the numerator. This times this term, the x's cancel, so I've got a times x squared plus 4. This times this term, the x squared plus 4 is canceled, so I get bx plus c times an x. All right, so now I'm looking for the y's values to choose. Always start with that. I see that 0 is a good number. So if I let x equal 0 on this side, so x equals 0, that's gone, so I get 4 from the left side. Oh, I didn't write it down here. 4 from the left side. And if I put x equals 0 here, I get 4a, and so that's how I got a is 1. All right. There are no other good values for x. So do not go choosing random numbers to plug in. You'll just get systems of equations that will be challenging. So let's look for the x squared terms. So here I have an x squared term. Here is an x squared term. And if I thought about it, there's an x squared term here. So I get 2x squared equal ax squared plus bx squared, right? 2x squared, there would be an ax squared, and from multiplying this out, I get a bx squared. So I get 2 equals a plus b. I know what a is equal to, right? A is equal to 1, so b must be equal to 1. All right, so then I'm going to go find or compare the x terms. So here's my negative x, and there's no x terms in here. And over here, there's a cx. So I get negative 1 is c. That was pretty straightforward. Okay, so now plug it all back in to this. Has to be written neatly enough so you know where to put things in. So I'm putting a as 1, and then I've got b b is, where's my b? Here's b is 1, and c is -1, right? Here we go. So this is an easy integral, but then this guy here, what am I going to do with this? Not very profound, but very important step. This subtraction in the numerator split the fraction up. So I get x over x squared plus 4 minus 1 over x squared plus 4. This integral here needs u substitution. So I would let u equal x squared plus 4 du will give me 2x dx. So I'll get 1/2 du is x dx, right? So that this turns into 1/2 1 over u du. This is this one, right? This one here, do you recognize it? I just pointed it out to you. That's your arctan. So this one, after I take the antiderivative, put the x squared plus 4 back in. I changed it to parentheses because x squared plus 4 is always positive, so it's okay not to put absolute value bars. This one has to have absolute value bars, right? Integral of 1 over x is ln of x, and then my arctangent. All right, just going to point out, if you have my quadratic repeated, so taking this fraction here, I would start with a over x, and then I would take this to the 1 power. X squared plus 1 all to the 1 power would get a bx plus c. And then x squared plus 1 squared would get a dx plus an e. So this is much more challenging, and I'm not going to go through and do this one, but just wanted to make sure you knew how to set it up.